Arca is big beam territory. It's been around since 1999 and have pursued a true variety of launch concepts. Many people consider them to be a scam. However, let's take a deeper look into their claims. So recently they did a keynote called the Future of Rockets, in which they presented their concepts for a small lift launch vehicle, as well as a super heavy lift launch vehicle that both utilize steam-based propulsion. The Future of Rockets presentation was based on their launch system papers, so we'll discuss them as well. Rocket is a very small lift launch vehicle with a payload capacity of only 10 kilograms to LEO. It uses one small LES booster to give the hydrogen peroxide kerosene second stage the required assist to reach orbit. The LES booster is planned to be reused, being a VTOL booster with a dedicated landing engine as well as a drogue chute. The first stage acts like an air launch with similar altitude separation, though at a velocity that is around 3 times higher compared to conventional air launch systems. It's roughly 857 meters a second versus 274. Also, a quick explanation of hydrogen peroxide as an oxidizer. When exposed to a catalyst, hydrogen peroxide decomposes exothermically to form water and oxygen, which is 1000 degrees Kelvin. This hot exhaust can then be used as an oxidizer and is hypergolic with most fuels because of the heat of the oxygen, making it very reactive. The price per launch of the system is reasonable, although most launches creep in price from initial announcements, so I think it's probably lowballing it. Other very small launch vehicles have gone for low prices. Perigee Aerospace is aiming at 2.3 mil for the Blue Whale 1, which is a LEO capacity of 71 kilograms. You can also see Vector Space in the graphic, which aimed at 2 mil for 60 kilograms to LEO. Both of these vehicles were arguably a significant factor more complicated compared to Rocket, so it seems that the pricing is in the right ballpark. They're only expending a 40 kilograms second stage and fairing, which should be reasonably cheap to manufacture. The mass for the second stage is also pretty reasonable. Again, Blue Whale 1 had a total dry mass of 100 kilograms. I could definitely see the launch price of Rocket being less than 1 mil. $390,000 for a 10 kilogram satellite is likely a bit expensive. It's definitely not competitive for small sat constellations because those can ride share and stuff like Electron and Falcon 9 for much lower prices. But as a dedicated launch vehicle for research/university satellites in Romania and surrounding regions, I could see it being a launch vehicle of choice, so maybe a couple launches a year. However, €1 million development cost is questionable. The cheapest I've seen for a development of an SLV is $14 million USD with Landspace's Zhutrui 1, and they basically just purchased their solid stages from a Chinese SOE. Rocket is definitely a small rocket, and it leverages a lot of history from previous work at Arca. However, it's still ambitious to develop a rocket for a price where the design launch cost is a significant fraction of the dev cost. And you can see that they're having to take shortcuts in certain areas, like skipping thrust vector control for the first stage and instead opting for RCS. This rocket is a significant downsize from their previous LAS 25R plus HAST-2 CA Mini, and it comes from the fact that this rocket is aimed at winning a European SLV design contest with a prize of €10 million. Honestly, as far as design for an Arca launch vehicle goes, this is fairly optimal for them. It leverages a lot of their heritage while being as small as possible to give them the best possible chance of completing the project. Heavy was the other rocket presented in the Future of Rockets keynote. It has a big LES first stage and a large hydrogen peroxide kerosene second stage. Simply speaking, it's just a significantly larger version of Rocket. Heavy design-wise is an air-launched big dumb booster aiming at a LEO capacity of 60 tons. We'll get into price per launch later, but I just want to discuss big dumb boosters. Big dumb boosters is a general class of launch vehicle based on the premise that it is cheaper to operate large rockets of simple design than it is to operate smaller, more complex ones, regardless of the lower payload efficiency. Yes, I did get a definition from Wikipedia. By building things at scale and placing primary emphasis on cost over performance, you could potentially reduce the cost of launch by like a factor of 2 when compared to more traditional launch vehicle designs. The example that everyone knows about is the Sea Dragon, because, that rocket was metal. However, I think another rocket is more pertinent here. There was a company that investigated a kerosene hydrogen peroxide fueled big dumb booster concept back in around 2000 called Beal Aerospace. The BA2 would have been capable of 17 tons to LEO and was aiming to reduce launch costs by a factor of 2 when compared to the Atlas and Delta series of launch vehicles. They did get around to firing the second stage engine, which is still the third largest rocket engine ever fired, as far as I'm aware. They gave up because they weren't willing to compete with the NASA-subsidized reusable launch vehicle program that was going on, which is kind of sad because that program ended up amounting to nothing with the cancellation of the Venture Star. So in this way, I don't think the basic principle of eco-heavy's design is dumb. A big dumb booster using hydrogen peroxide and kerosene as propellant could be reasonably cheap. However, the cost of eco-heavy, yeah, there's some serious shenanigans going on here. To begin with, let's look at the pricing of this super heavy lift launch vehicle. In the first LAS paper, this was priced at 40 million USD, which is already very ambitious for the size of the launch vehicle. I could see it happening, but I'm skeptical to say the least. Then, in the second LAS paper, they've already managed to reduce the price to 30 million USD. Incredible, right? They managed to shave off a quarter of the cost of the rocket in a year. Some serious dev work going on over there, despite there being no obvious design changes. But if you thought a reduction by a quarter in price was amazing, wait until you see this last one, because in the Future of Rocket's keynote, they managed to drop the price by a factor of 28 to $1,080,000 USD. How did they do this, you may ask? What engineering marvels did they pull off? Did they micromanage cost off the planet? I think I might be able to recreate the specific steps that Arca went through to reduce the price per launch. Let me show you. I think the better question is, why did they reduce the price by a factor of 28? Well, they want to sell Eco-Rocket Heavy as Europe's answer to Starship, so it has to be cost competitive. So they looked at the aspirational price of Starship, $2 million per launch, and looked at its dollar per kilogram, which with 100 tons ends up being $20 per kilogram. With a price point of $1,080,000 USD and a LEO capacity of 60 tons, you end up with exactly $18 per kilogram. This is why you don't take Arca seriously, jeez Louise. From what I can tell, they were hoping to attract investors' money with their previous LAS papers, and they didn't get anything. So now they go, well, we have to go more ambitious to attract funding. Position Eco-Heavy as Europe's answer to Starship, and we'll get all of the money. That's how SpaceX does it, right? Even the development cost of €30 million is questionable. Well, of course it is. It's equivalent to the previous price for launch of the rocket. For example, the second stage engine of the Hearth Heavy is a big kerosene hydrogen peroxide aerospike. It has a thrust of 1,240 ton force, which in kilonewtons is 12,160. For reference, the F1 had a thrust of 7,770 kilonewtons. They wanted to develop an aerospike engine that has 1.5 times the thrust of the S1 for 30 million euros. In fact, it's actually significantly less than that because you have to factor in the rest of the rocket. They want to develop an engine that's more complicated than the F1 for less than 30 million euros. What? Anyway, that's enough dealing with Eco-Heavy. Let's discuss the basis for all this shenanigans, the LAS papers. LAS refers to Launch System, which is a catch-all term for their steam boosters. So this is a slide which they showed in their presentation, which is the basis for their claims in regards to steam boosters being able to replace regular SRBs and being able to assist a launch vehicle. This is the third time that they've released this specific graphic. It was also in their 2 LAS papers. The second one, which is supposed to have revised everything in it. Okay. To begin with, let's revise the naming of the Atlas V variants. The first digit stands for the fairing diameter, which is generally either 4 or 5 meters. The second digit stands for the number of boosters, and the third digit stands for the number of RL10s on the second stage. So the Atlas V 500 would have a 5 meter diameter fairing, 0 SRBs, and 0 RL10s, which would mean the second stage would have no engines. Interesting concept. So straight up, it should be the Atlas 501. Secondly, I don't know how to say this, but Arca appears to need to hire some 7th graders to do percentage maths because clearly they are lacking. Like, how do you mess up percentage math as an actual adult? But don't worry, this is only the 3rd time this table has been published in Arca documentation, and not once was a math checked. Apparently they revised the whole document on the second issue, but this seems to be a lacking check. However, what surprised me is that 4 LAS 50E boosters can potentially meet performance increase associated. Also worth noting is that it's roughly the same as the performance increase associated with one AJ60. They haven't stated a price for the LAS 50E, though 1 mil is probably in the ballpark. In this case, it does mean that the 4 LAS 50E boosters are cheaper than the 5 mil AJ60 and are also pollutant free, which is pretty big. Though the Gem 63 will reduce the price per SRB by 40% to 3 mil, so it starts being cost competitive at that point. However, I feel like this ignores the role of SRBs, which is to help the launch vehicle reach a required performance. The issue with LES boosters is that pretty quickly you A. run out of space to attach to the boosters, and B. run into diminishing returns to the point where you get next to no payload improvement adding more boosters. You can use larger boosters, but they actually have worse mass fractions, so the performance for a net similar mass of boosters isn't actually improved, and you still run into diminishing returns, unable to meet the high performance requirements. Using LAS boosters to replace SRBs limits the ability of the rocket to meet high performance missions, so any of these listed Atlas 551 or Atlas 541 missions you just couldn't have launched. And I think that's a good segue into this next part. They've also released another table on replacing SRBs with LAS, and this one is a lot less well polished, if the first one was even well polished. In this table, it states that LAS 500E could replace the Ariane 62 boosters and provide the same mass to orbit capabilities. Because, they provide the same thrust, they should provide the same boost, right? However, this is where efficiency begins to matter. You see that providing the same thrust, and the LAS 500E booster actually has more propellant mass. However, it only burns for 1/6 of the time of the rocket, as well as having a worse thrust to weight ratio. I checked the performance on Silverbird, and this time it wasn't so positive. The LAS boosters Ariane 6 had a capability 1/2 of the SRB Ariane 6. These numbers for the payload capacity are complete fabrication, which is sort of obvious from the fact that the capabilities are listed as the exact same and not even slightly different. In fact, even the mass of the rocket is the same, despite the fact that the LAS boosters weigh significantly more compared to their SRB counterparts. I guess they just didn't bother with this table, It's hard work creating accurate documentation. Why would you even bother? This is why people call Arca a scam. They're straight up lying about the capabilities of their boosters to sell a product, and they published this twice. So they say they revised the entire document, yet they weren't revising well enough if they're just publishing scam, I guess. For climate change, global warming, launch vehicle pollution is minor. In 2018, the global CO2 output of rockets was only 0.000059% of all CO2 emissions. The issue is more with SRB exhaust because those have fairly problematic exhaust products. Yes, in certain instances, LES boosters can replace an SRB, which does fix this problem. However, the performance just isn't there for a lot of applications, so it's a moot point. If you want to replace SRBs, developing a cheap high-thrust hydrogen peroxide kerosene booster would be the way to go for Arca instead of trying to force such a low ISP system to work. So as of 13th of February, they still haven't done the actual hop of the Eco Rocket first stage. This timeline was set on November 18th, so when they announced it, they were 18 days from a hop. It's now been 86 days, and this test still hasn't been conducted. That's a minimum selector by a factor of 3, approaching 4 now in your timeline, and the hop still has yet to be conducted. So it appears that these timelines are completely arbitrary, was set without any plans to meet them. I don't know, that just seems like that to me. In fact, that might be the case. The basis for the June 1st orbital attempt goes back to the contest for the 10 million euro. One of the things that was listed as a thing that would increase the score in the competition was an orbital demonstration flight. Well, why does that make me think that the competition is the basis for the time? Well, the competition closes on June the 1st, so they wanted to complete the orbital test flight in time for the submission deadline to give them the best chances. And if you see the goals that were set out in the Arca timeline, they match pretty well to the elements in the criteria. They have stated the cause for delays is funding. However, if you're only 18 days away from a test, I really feel like you should be confident in your funding and your timeline. That's just me. Given they're already off on their timeline of the first goal by a factor of 3, you can probably guess what I think their chances of meeting the rest of the timeline are. A surprising realization that has come over me over the course of researching this is that the basic principles behind this design of the rockets presented isn't inherently dumb. Big dumb boosters, okay. Now, are a viable, interesting concept in my opinion. Hydrogen peroxide is an undeveloped oxidizer, and steam boosters, if they meet the metrics as stated in the document, can in certain cases replace SLBs, though I would prefer just straight liquid rocket boosters. And if a company were to propose the idea, I might give it some thought. Well, as I have. But it's Arca. And Arca is Arca. They're outright lying here, in many cases, and hopefully fooling some investors into giving them money. And you can make of that as you will.